Okay. Hi, everybody. I'm Justin Grote. Thank you so much for coming to my talk today. Today's talk is Everything Fast, Writing Performant PowerShell Modules. Today I'm going to be talking about a couple different modules that I've written, a module called ModuleFast, which is a fast declarative way for installing PowerShell modules, and another module I'm working on called ExcelFast, which is a fast way of reading and writing Excel files and CSV files in a performant, low-memory manner. And we're just going to go through and kind of look at a little bit of like a PowerShell approach to doing some optimization, and then like a more low-level C# approach. And kind of the idea here is to kind of give you an idea of where performance problems often occur and how to fix them. Since this isn't a super long talk, this is going to be mostly a high level, and then we'll have questions at the end. And if you want to know more about ModuleFast and ExcelFast after you see them, we can talk some more about those. I want to thank all the sponsors as usual, Jane Street, Chocolatey, Ironman Software, Knowledge Factory, Synergy. They make this happen. They do the sponsorship. People like Adam Driscoll of Ironman Software, flew out here. He's great. PowerShell Universal is awesome. Just one of the many options that are there. But again, thank you to everybody who's doing this. And a big thank you to Allied Digital, my company, for sponsoring my travel to be here. We are a multinational MSP, and we do a large portion of infrastructure management and a whole range of services. Elevator pitch is basically you don't manage your plumbing, you don't do your water, you don't do your sewer, you don't do your electricity. More and more, you don't need to do your IT anymore. You can focus your business on what your core competencies are, whatever the product is that makes you successful, and we can handle all the rest of the infrastructure for you to make you successful, make your employees successful, etc. So if that sounds good to you, and you want to be backed by people like me who make the stuff work, give us a call. Again, I'm Justin Grote. I'm a data center solutions architect with Allied Digital. I am a 5-time Microsoft MVP, which I did just fix that, and it went away, whatever. Hopefully 6 by July. I'm responsible for a bunch of different modules in the community. I'm one of the community maintainers on the VS Code PowerShell extension. Either this year or last year, I am now thankfully officially also a contributor to the PowerShell repo because I had a couple pull requests merged. So I'm very proud of that. And a bunch of other tools that from secret management to things. I like to make a lot of stuff and I get bored easy. So that's how these things happen. And that's it for those go. So we're just going to go right into doing some performant modules here. So where we're going to start here is if you've ever gone to install the AZ module, you know exactly what this looks like. If you go install PS resource, AZ. Yeah, I'll get it next. I was just going to. It's all PS resource AZ, and we'll just do verbose just so we can see what it's doing there. Yeah. Oh, snap. I know what happened there. 1 second. My computer decided to go super res. Quick fix. Right off the bat. How about now? Might have to pull it. Overwhelmed the projector with my superior 4K screen. Made it beg for mercy. All right. So anyhow, so I just started up AZ running there. And so here we go, and we're going to install the package, and now we're installing the AZ module. Whoever's ever done install PS Resource AZ? How long does it take? 15 minutes? 20 minutes? Maybe? Like, we'll see how it goes. This is sort of an example of a place where maybe there's some optimization that can occur. So when we look at what this is doing, we can see, okay, well, it has to find the packages and then decide what it wants to do. But one thing we notice is that it's just sort of grabbing one package, and then grabbing another package, and then grabbing another package. And is there any reason why we can't just pull all the packages from everywhere? And another thing that's kind of interesting is that the backend that it's talking to, it turns out every time you talk to the PowerShell gallery, it takes like 400 milliseconds for every little query you do, which is not a lot for one query, but when you're trying to install hundreds of modules, it can be an issue. So how about we try, if we just do a split here. So what ModuleFast does is it just sort of takes some of the areas here where there's just some air and space and fill them in by first declaratively allowing you to define what modules you want to install in a declarative manner like you do in Terraform or Ansible and such like that. Being able to define what you want your desired state to be in terms of modules, allow it to develop a plan for you, and then when it goes to install the modules, do it in a very rapid manner. So if we do install ModuleFast AZ, I'm just going to install it to a different destination here. Module test for fun. Install ModuleFast AZ destination module test I'm going to do this extra parameter, just destination only. This just says ModuleFast is smart enough to look at your computer that's what's already installed and not try to download something that you already have that satisfies your needs. This just tells it, like, ignore any other folder. Like, if it's not in this folder, don't worry about it. So this is just so that you'll be able to see it do that thing. And I'm going to go ahead and add verbose to that. And so now it's resolving the dependencies. And there you go, 93 modules of AZ installed. So that's ModuleFast versus over here with PS Resource Kit version 3, 10 seconds versus 154 seconds. So that's a fun little demo. And then, and again, if to do it again and to see if there's any updates, if I do this here, it knows immediately based on my spec, because my spec is just whatever the latest version of AZ is. There's nothing new to install. So just like that, it knows, okay, you're up to date. If I were to go and delete a module in there and say, do it again, it will be able to see that, okay, there was a module missing, and then make it complete. So it's idempotent and declarative in terms of deploying these dependencies. So that's a neat thing about ModuleFast. It does all that kind of stuff. If you want to check it out, it's got a module here, and here's all the details. My favorite logo, which you used to do this on the PowerShell gallery too, and I broke it, and I need to figure out how to fix that. But so this will give you all that information about how all that works. But let's look a little bit into the code of it. So ModuleFast, by the nature of it, we built it to be very fast and also to be bootstrappable. So in order to first get ModuleFast, it wouldn't make any sense for us to need to install, the tool that is not the fastest at installing modules to use to then get ModuleFast. So we have a way to get ModuleFast, which is to just do this. Just pull down this script and then run it, which will rapidly pull down ModuleFast and then load it into memory temporarily. And there's a couple different things if you look on the site. If you want to just do it as a one and done thing to install the dependencies or whatever and be done, you can do that too. And this comes from, even though this is like a bit.ly link, it's actually tied to a GIST and it's all signed and all that kind of stuff. I would argue this is plenty secure, especially if you point directly to the GitHub GIST and the link. Basically, somebody would have to compromise my MFA passcoded GitHub account to be able to make any changes there. So otherwise, you can just use the standard gallery to install it. But this is just another example of very quickly going out, fetching a model, getting it ready, and now ModuleFast is ready to use. Command-module-ModuleFast. So now it's there. It's got all the stuff, can do the planning, all that kind of thing. So the way that we do this performance-wise is that in order to make it work in this way so that it can have that kind of performance and be able to just be pulled down anywhere, it was designed to be written completely in PowerShell. So everything that I did there, there's no binary modules really involved in the core of that whole process. Everything I did to fetch data and grab and do all that is done within PowerShell. So in order to do that, of course, we have this very, 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 very long script. And the reason it's all in one file is, again, for that performant reason, to not have to fetch a bunch of different files to be able to get it all in one. But effectively what this does is, as we talked about, we take a lot of concepts that we have in terms of the module. A lot of the prelude of this is primarily just all about like defining the types around how we get our information, all those things. But as far as the installation process, the core of it is mostly handling around setting up an HTTP client, basically going even below using invoke REST method and invoke web request, and using the piece of .NET that those are built upon, which is this tool called HTTP client, which is a HTTP library that Microsoft provides as part of .NET. It comes built into the core of it. It's not a separate package. And this is what you can use to go ahead and run these tasks. And so one of the nice things is that there are ways to utilize tasks which are not super easy to work with in PowerShell. If you've ever tried to use like a .NET asynchronous interface that will give you a task back, and you're just like, what do I do with this? There are ways to await those and do loops on those things and that kind of thing to make these things work. So if we get down here into sort of the body of the process, once we get past all these things, I just kind of want to skip down to the install part. So here's an example of just sort of doing a loop, and you don't have to go all the way to the .NET level like I'm doing here, but if you can use things like for each parallel and those kind of things to accomplish the same thing. But the whole idea is simply that rather than if you have a process that's, do this, then do this, then do this. In the same way you might go to a server to check something, and then go to another server to check something, then go to another server to check something. If you have a way to just check all those at once, if there's no dependencies between those, like if you don't have to check this server to then know about something on this, if there's no dependencies in those tasks, why not do them together? This kind of parallel and concurrency thing is sort of one of the best ways to make any kind of script more performant, because PowerShell, by its very nature, in being simplistic and being declarative in a nice straight process, ultimately only most of the time ends up using like one core on your computer and is bottlenecked by your one network request waiting for it to come back. So if you have ways to parallelize that and make it more efficient in terms of being able to do that, that's usually the number one place that you're going to get gain. So I'd say like 60 to 80% of the gain that happened here is because of that point, is that I'm able to go out and fetch all the modules at once and then pull them in, and then do some other tricky things with disk, like you'll see here where I'm actually grabbing a stream and taking that information rather than like getting it all first and then acting on it. What other tools like PS Resource Git do is they get the package, they save it to disk, and then they unzip it from the disk back into memory and then go and write it over here. Well, this seems like an unnecessary step to write it to the disk, especially in an environment where we have way more memory. So if we just accept that in our case, we don't need to be in a really super memory constrained environment, and even if we are, this just runs slower. What if we were able to just pull the information as we read it from the site, from whatever website we're pulling it from, and then read it into memory, and then from memory with that stream, as it streams in, just go ahead and unzip it and unspurl it as it comes, and then just write the module files to disk. So by doing that in ModuleFast, we're skipping an unnecessary step. We're not writing to disk and then reading back in and then writing down again. We're just writing down directly. So that's another example of like an optimization technique that you can use. And while I did this all in PowerShell with a lot of really fancy .NET stuff and all that kind of stuff, that can be as simple as just you change how you write your script to be in parallel, or maybe there's certain things you're doing that aren't necessary. Maybe there's faster places you can write that might be more expensive, but depending on what the parameters are of the environment that you're deploying in might help. If you're deploying a script for Azure Automation, you have a very, very limited memory ceiling. But if you can use like a hybrid runbook worker in Azure Automation, now you've got all this memory. And now that you have all this memory, maybe you can do certain things more in parallel and faster. Everything in computing is a trade-off. And you're always trading something for something. You're either trading something from being lightweight to something being, flexible, something being performant to something being, efficient, and something being, high power, using all the resources, to something that can run in something as small as a Raspberry Pi. And ideally, we can write things so that they can detect these things and adapt to them. And .NET is really good at doing that stuff with things like the garbage collector and all kinds of sensing for memory and memory pressure. It does a really good job of that for things like memory. And for things like threads, we can do that too. But if we're aware of those and we're aware of what the parameters and constraints of the environment we want to deploy into, then that allows us to do more things. And if we're able to raise the floor, a lot of extra CPU and memory solve a lot of sins. How many here have a SQL developer that, demand a new 64 core, 2 terabyte thing, and then you do like a query analysis for them, and like, if you just like change this query analysis to only grab one field rather than the entire table, it'll be faster. It's stuff like that that's like sometimes you can either just hide it with power, or you can find a way to make it more efficient, not grab things that aren't unnecessary. So in that spirit, let's look at ExcelFast. So ExcelFast is a module that I have started that looks at sort of the existing options that kind of exist. And, in our environment, with what I do with my company, we deal with a lot of very, very large Excel files. We have things coming in, not just Excel, but CSV, just any kind of flat reporting files that come in. They come from everywhere, from reporting systems to analysis systems to logs to JSON to all these different structures. And, sort of the existing tools started to become a little bit of a problem. So I'm just going to go ahead and bring up a program called .memory. And this is a neat little tool that lets you, for any .NET process, of which PowerShell is just a .NET application, watch in real time the memory of what's happening. So we're going to go ahead and go to let's go with this process here. And actually, I can just do this as one. Let's do a freshie. Okay, so that's 16760. There he is. We'll go ahead and start watching it. doesn't crash my machine. So if you look at this graph over here, this just sort of shows the memory that's in use, and you can kind of see the types. If you don't know these terms, don't worry about it. This just mostly just has to do with different kinds of memory. So there's this unmanaged memory that we don't touch. This is just stuff that happens out there. And then there's stuff that the program controls. So I just started PowerShell, and so there's very little of these heap generations, which are basically like the main memory in .NET. So if we have this, let's go ahead and change to ExcelFast. And in this is under my test folder, I have some fixtures. And in here, I have this file here, which is a 1 million row Excel file. So we can just start very simply with the, let's see if I can get this. This is a little tricky because you can't really shrink this guy very well. So this is going to get a little crowded, and I apologize for that. But if we go ahead and have here, and we go ahead and import, we'll just do the 10, for example. Oops, let's do import. So like we'll use like import Excel, which is sort of like the most common use for this kind of thing. We'll just do test 10, XLSX. You know, pretty standard, 10 fields, 10 rows, works pretty good. And you can see here on the graph where it kind of spiked up. Did that work? Unmanaged memory went up a bit, but you know, more or less not too bad. But let's see if we try to do it with 1 million rows. And I have to do no hitter. Now we have this thing taken off, trying to process it. And we can also show with our performance graph, you know, we got 60% here, we got 9 gigs of memory, and we notice now this is just going up and up and up. That's a lot of memory. Like we're getting the, we'll zoom in here and just kind of get there. Oops, I must missed my point on this guy. So you'll see it's just going to keep growing here as it reads in that value for that. And we're going, and we're going. And we're going. So there's a few things here is that, you know, the two, and this is nothing on import Excel itself. It just has to do with like it was designed with different libraries that had different objectives. More about like reading for compatibility, reading with older tools, having a lot of not the optimizations that exist in newer versions of .NET. And so often if we want to do processes in a better way, sometimes we have better techniques to go about that. You can see here it's trying to do that, getting that information, still jamming on that, still running, still processing. I've never been able to get this complete. I've let it run for 4 hours and it never got all the way to, I either ran out of memory even on a monster machine or, you know, ended up just having it die on me. So we'll go ahead and cancel that out if it'll even let us cancel it. Okay, there we go. So that was like 77 seconds so far. So what we can do instead is that we can, if we make a module that, we'll go ahead and clear the garbage here, garbage collection, get kind of back to our baseline. That's kind of where we started. Zoom in over there. Oh, I snapshot it. Didn't mean to do that. There we go. So we're kind of back to normal where we were. So what instead we can do is, where are we at with this? That's a lot of unmanaged. Let's go ahead and kill it and redo it just to start fresh. So what we can do is that when we are looking at these, we can look at different libraries. And so in this one, I found a library that was designed to be as minimal on the allocations, putting it into memory as such, and really focus on like the streaming aspect of being able to read a file. And so it makes it so that an Excel sheet becomes this thing called an IEnumerable, which is a very low-level .NET concept that just simply is an interface that just defines something that can be paged over. And it's just a really easy way that if you write something that supports that, the most popular of which that you know is called the PowerShell pipeline. Anything that implements this sort of IEnumerable thing can be iterated over and so move next. So what this library does called Mini Excel is that it's designed in the most performant way to be able to read that Excel file, which is basically a glorified zip file with XML in it. These days, that's what an Excel file is for the most part. To be able to go in there and, you know, go in and find the bits and seek to the right bits and read it, but only read it when those rows are requested. And so by doing that and taking a lot of the extra stuff out of it, not trying to read the whole file in at once, we can have a much more lightweight streaming approach. And so we'll make sure this is the right PID here. Yep. And we will try import workbook instead on that same file. Oh, I meant to save that to a variable. So here we go, same thing, but you'll notice the amount of memory usage instead of in gigabytes is in megabytes here. And you notice that the garbage collection is constantly running down here. So it's basically, as it's reading each row, it's being taken care of and parsed, but getting saved. So we have this real linear thing of that, we have 1 million rows, and so that's all getting saved into this file. And so as we go, we have this sort of much more efficient, much less stepwise approach of just reading in that data. And so on sort of my computer at home, this takes about 8 seconds. On this laptop, which is about 2 or 3 years old, it takes about 24 seconds, if I recall. We'll see. Maybe it'll get mad at me because I didn't do something. And then, in some of our larger systems where we're doing these kind of really high-end processings, this fans out on multiple cores, does all that kind of stuff. So it's able to take advantage of all that hardware and really be able to collect all the information that you need. And so it took 55 seconds, probably because I had a bunch of other stuff going on and that kind of thing. But as you can see, it actually completed, and the actual memory being used of that 1 million lines of data is really not that much, because it's able to just pull out just the data that was needed. So we're going from a tool that just couldn't even read these files, but has a lot of nice compatibility, to something that was able to read it in 55 seconds or 17 seconds or whatever. And so when you're developing these things, it's always good to look for what might exist out there that can help you. So in my case, as I mentioned, there was the mini Excel thing. And so if I go here into the commandlet for this import, it's really not that complicated of a process. It mostly just comes down to getting the file, doing a bunch of checks. It's always all about checks. Make sure the file exists. Make sure that there's not an unresolved thing. You get all this kind of information so that you can leave really nice error messages to guide people in the right place if something's not working. But in the end, we just end up having this IEnumerable of rows, and we just go ahead and grab the sheet and read the information in. And once it's read in, then we have it. Now we can do that. But here's one of the neat things is that because we're using an enumerable, PowerShell has a really good thing because it knows how to work with enumerables on the pipeline to do some cool things. So what if you don't need all 1 million lines of the file? What if you only need 10 lines of the file? Well, if you do select first 10, again, you don't need to know .NET for this. You don't need to know anything special. Because it's an IEnumerable, it works with the select command. And what select's going to do is on the pipeline, the whole pipeline goes each time, and all select does is when it gets to that 10th event, it stops the pipeline. At the low level, it sends what's called a pipeline stopped exception, and then you just have to handle that if you want or not. And then that just tells everybody that's behind it on the pipeline, like, hey, stop sending me stuff. Now, if you try to do this with like import Excel, doesn't matter because import Excel is not built for that. So if you go to do it, it's just going to continue to try to load and try to do it, and none of that happens. But if I do the select first 10, in 0.02 milliseconds, I was able to read 10 lines out of that 1 million line file, as opposed to having to read the entire file and then only get the 10 lines out of it. So this is just another example, like when you're optimizing for performance, maybe you don't need all the data set to do the job that you need. A really common one of this, if you've done Active Directory, is if you've done select all users, by a certain property, select all users based on your criteria, and it takes a long time to load, and you end up with a ton of memory because you've loaded in every single property of those users. But then if you had that dash property SAM account name or email address or whatever, just the one thing you're looking for, suddenly it runs so much faster and also completes quicker, and you have smaller memory, so you're able to work with just the data that you need. So if you're building any kind of thing that is slow, maybe you're pulling too much information from some SQL database, etc. Now, ultimately, sometimes what you're pulling from might be the issue in and of itself. So if you're pulling from a site like the PowerShell Gallery, there's an inherent limitation that you have, whereas the PowerShell Gallery today, the way I understand it, is mostly just a giant SQL server that uses NuGet version 2. And it has that 400 milliseconds. So it doesn't matter how fast I make ModuleFast on the client side, those queries are still going to take that 400 milliseconds each time. And if you multiply that by the number of queries you have to do to import the AZ module, that's a big problem. So what if we don't have to use the PowerShell Gallery? So what I did is that I made a complete mirror of the PowerShell Gallery. And so when you use ModuleFast, it actually goes against this. And all it is that there's this really nice thing is that NuGet version 2, which is the protocol that when you get your PowerShell modules, when you do install module or PS resource, what you're actually fetching from the PowerShell Gallery are what are called NuGet packages. And NuGet is this sort of, if you use C# or .NET, it's just sort of the standard packaging for assemblies and such. And when they started making PowerShell, they decided, hey, this is a pretty good format. We don't need to reinvent the wheel. Let's just go ahead and use these. And so what they are is they're just basically, glorified zip files. Zip is so universal and supported that why use something else? It's just a glorified zip file. You can fetch those new packages, unzip them, and put them down. So, but the protocol to do that in NuGet version 2 was sort of Microsoft proprietary. It was never really documented, and it requires sort of an API to work with. It's a database. It was built on OData, which is this real standard sort of SQL object-oriented way of getting data in a decoupled way. So the people who make NuGet got to really thinking about it, and they were like, do we really need all this infrastructure? So if you go to like NuGet.org, which is what Power C#, they came up with a new way to do it. And this is NuGet version 3. And what they decided is like, do we really need any intelligence in the process at all? Like, why can't we just have a JSON file that's a registry? And that JSON file can have a list of where to look for packages. And then the client can say, okay, I know this. If you point me to here and I'm looking for the AZ module, I can just go to this path/AZ/index and then get that file. And that file will tell me what versions are installed or what versions are available in the registry. And then I can just grab that JSON file, which will tell me where to get that package and be done. But if I do that, then you don't need a server. You can just use a file share or any kind of dumb HTTP service. So by doing that, things become much more cacheable, because if you want to fetch the latest if you want to fetch AZ 3.2.0, AZ 3.2.0 is never going to change. So you don't have to resend it or do all that work every time. You can just serve it out. So what I do is I create a complete mirror of the PowerShell gallery. Who here went to the Sleet Talk? Who did the Sleet Talk? It's killing me. Adam, thank you. Yes. So yeah, Adam Driscoll did the Sleet Talk on which lets you build these sort of NuGet version 3 static sites that let you host PowerShell modules. Who went to that talk? Okay, great. This uses Sleet. This is Sleet on steroids. This is Sleet, but using Sleet to mirror all 300,000 packages in the PowerShell gallery. And to do that, I use just a simple, this is an Azure container app, which is more, think of it kind of like an Azure function, just only using containers instead of the function infrastructure. And the script is pretty straightforward. It really is more or less just go to the gallery, get the latest, do a search on the gallery for any modules that have come up since the last checkpoint. I save in Azure a little checkpoint that's like, okay, I know I have all the modules up to this date. And if there's any new modules that come out, go in, fetch them with invoke REST method, and then publish them using Sleet. And here's the Sleet part. And then roll forward the checkpoint once we know we've added it to our gallery. And so this just runs about every 15 minutes or so. 5 minutes, 15 minutes, doesn't matter. Runs in sort of a serverless container way, so it's very cheap. See if we can find a big one. That usually means there was a new module pushed. And if we look in our logs here, this is all just PowerShell. This is literally just that script running here. And this one just took a little longer than usual, but you can see, checkpoint, went to check the packages. There's no new packages, nothing to do. But if I were to go and push something to the gallery right now, the next time this thing runs, it'd say, oh, Justin pushed ModuleFast 1.2.6. I'm going to grab that and add it to my static gallery. But now I have something that's not dependent on the PowerShell gallery anymore. So not only is it not dependent to the issues of the gallery with its CDN issues and the SQL servers and any of those kind of uptimes and patches, it's all just all this just gets dumped into an Azure storage account. And then further, that Azure storage account is fronted by Cloudflare, which is this big global CDN. I could have done this with Azure CDN, but I just chose Cloudflare because it was free and has more coverage. And so you can see here over the last 30 days, I have 172,000 requests for whenever you run install ModuleFast, all those little things that you saw, like grabbing JSON, checking those, that's all these requests here. And of those, 90% of them can be served from Cloudflare. And of that, most of those are just the JSON files, because whenever you update, if I push you a new AZ package, now that file is invalid, that registry. And so when you go to search to see if there's a new AZ version, you now get the uncached version up until the next one comes out. But any one of those files only ever has to be pulled once. So if you look at the traffic here in ingress and egress, it's measured in just megabytes. That's 7. Sorry, I know that's really small, but you can see it's just measured in 7 megabytes, 10 megabytes, nothing. Every once in a while, a package, and I can keep my latency down pretty low in terms of the fetches. But as far as the gallery goes, since it's all coming from Cloudflare, which is this big distributed network that even though that gallery might be in West US with a mirror in a couple other places, if you have a CDN in the ISP next to you in New Zealand, you're just going to go there at whatever the fastest speed is for your ISP. You don't even have to cross an international wire to get that data. So of the 151 gigs of modules that I have served from here, only like 15% of them were cold misses because, as I mentioned, those files don't change. They're all static, and now they're cached, and we're able to do that. So that's sort of the final lesson here of performance enhancement is don't send things you don't have to or that you already know about. If you fetch information from a system and you know for sure that information hasn't changed, why are you fetching it again? If you have a way to cache that and you can do it intelligently, one of the biggest jokes is that there's only two things that are hard in computing: naming things and cache invalidation. The first one everybody gets. Not everybody gets the second joke until you actually try to do it, and then you're like, oh yeah, that's really funny because it's impossible. There's a lot of great techniques to deal with that these days, but the short just being is that if you can cache something, then you can save that round trip in the same way of like, there's no point in writing to the disk and then bringing it back and then writing it back down if I can just skip that one step. So most performance optimization just comes down to, are you doing the minimum that you have to do to perform the task? And are there reasons that there might be reasons you have to do that, political, compatibility, whatever. But if you can remove those things where you're doing more than you have to, then that generally by its nature will make things faster. And I just want to close with this final point before I move on to questions. As I said up front, there is no fast, there is only fast enough. It doesn't matter if your script takes 12 minutes to run if the business is fine with that. If the business only needs it once every hour, why are you going to waste time investing in that when you have other problems you can solve? I mean, you can do it for your own glory and your own learning and your own kind of thing, but in the end, people get into these big arguments like, oh, this language is the fastest, this thing is the fastest, that thing is the fastest. What does it matter? If what you're using today works and it meets the business requirement, who cares? In my opinion, like really, who cares? Like other than to show off, who cares? But when it comes to be time that fast enough is faster than what you're trying to do, these are some approaches you can do to try to reach that goal and bridge those gaps. But as shown, there's nothing about PowerShell or even dropping from PowerShell to C#, etc., that for the vast majority of your business problems, you shouldn't be able to solve. You don't have to go to Rust. You don't have to go to Python. You don't have to. And again, always use the best tool for the best job, but you don't have to if that's where your knowledge is. So thank you very much. So yeah, for the next 15 minutes, I'm happy to take questions on just ModuleFast in general or any kind of performance things, or if you have like a performance question that you're having, maybe we can have a talk about that. But yeah, I'm open to questions on that, ExcelFast, whatever, anything I've shown today. Yes, Jordan.
I think I know the answer to this, but with your ModuleFast, did you end up pulling in dependencies, or is it...
Yes. Okay, so the question is, with ModuleFast, did I pull in dependencies? So everything is pure PowerShell except for NuGet version. I got so sick of dealing with, because the biggest problem with PowerShell is the most annoying thing is there are two version formats in PowerShell. There's the old style version format, which is the 4 digits, and there's the newer semantic version style format. So PowerShell 7.2 and up support the newer format. The problem is all the modules on the gallery, and several of them, use the old number format, and they use it in all kinds of crazy ways. There's -1s in there. There's 4 zeros. There's a 0.4.0.1, there's a 0.0.2.0, and to match that with semantic version and still do all the dependency resolution is incredibly difficult. ModuleFast, like the core of it, I probably wrote in 3 days, and the rest of it was just spent trying to get all that stupid versioning. There's this class called ModuleFast spec in here that it is basically just a class that I just throw these versions into and it figures it out. But the logic, and it's actually a PowerShell class, because I was like, oh, I bet I can do this without having to go C#. But if I find actually, sure, ModuleFast spec. Yeah, so class ModuleFast spec with no run space affinity and everything. You start here. Look at all these helpers, all these contains, all these equals, initialize, change, satisfied by. Yeah, it's a monster class. That, like, again, as you saw, that's like a quarter of ModuleFast is just that part. So it used to have a lot more in it, and ultimately I gave up. And so what I do is I bring in NuGet version. And what happens is that when you go to if you go to install from the gallery, it's already there. But if you use that bootstrap script that I use, I actually have a base 64 version of NuGet version because it's really not that big of a library. So I basically just have a version of that library in text that gets brought over and then brought into PowerShell using add type so that I have the assembly with me, but I don't have to go fetch a DLL or write a DLL to the system, which most AV systems totally freak out about. So so other than that NuGet version, everything else is pure PowerShell that you saw. So all the HTTP spec, now plenty of it just borrows heavily out of stuff that already exists in .NET, but all the task management, all the fetching, all the coordination of the tasks and doing all that stuff in parallel, I kind of wrote my own, it's not really like writing my own state engine. I just coordinated the tasks with like wait all, win any, all those kind of things that let you watch a bunch of tasks at once, and then when a task is ready to go, work on that and then go back to the loop and do the next one. So even though PowerShell is just this one single thread, and this also uses no run spaces. This is all, if you want to learn all about run spaces for PowerShell stuff, come to Jordan, my talk tomorrow. But in this particular case, even run spaces were too much overhead for what I wanted to do because you have to start up all this PowerShell stuff, and it wasn't necessary because what I wanted is these .NET tasks of having HTTP client just go and grab some data or having a stream go and do some zip stuff, and I don't need all the overhead of a PowerShell run space to do that. But I do need it to be written in PowerShell because I can't push an executable to make this work in some of the places that we needed to do it. So that's basically how that works. Yeah.
So is there a plan or something that this is something that Microsoft will take it? Because for enterprises, it's good to, like, for us, I mean, personally, it's very good to download it fast from your...
Yeah. Yeah, I understand. And so the question is like, will this ever be enterprise supported by Microsoft? And the answer is probably not. They have PS Resource Git. They have their plan there. And so, again, it comes down to, like, if you need this to be fast, it's fine. I mean, I can say that I probably have better uptime than the PowerShell gallery at this point, so it doesn't matter if it's Microsoft or not. Like, I mean, if you compare this literally has 100% uptime as across, because even when there's been, like, a regional outage in Azure, the Cloudflare is still sat up there. And so only basically when there was a Cloudflare outage did this fail. And so, and to the point that there are several, I know like Rob and like DBA tools, like there's a lot of companies that use ModuleFast in their CI/CD pipelines because it's more reliable than the alternative as well as faster. But again, the point of ModuleFast this is not for installing modules on your personal computer or installing them onto desktops. This is for CI and CD pipelines, that kind of thing where you need it fast and loose, and if it fails, it's not that big of a deal because ModuleFast, you can just retry. It's designed to fail fast. So if something goes wrong, like it can't fetch a package or anything like that, it will just immediately throw a terminating exception, and all you need to do is try catch it. You just say try again, and when it'll go out again, it'll know where it left off because it's idempotent, and it'll just pick up where it left off. If it got halfway done writing a module and it crashed, then when it starts back up, there's a checkpoint file that if it's not there, it knows to clean up that module and try again. So all of that's there. And again, the primary point, as I mentioned in the ModuleFast README, is that it's optimized for these high performance parallel implications, and I mentioned later is it's primarily for CI and CD. Like you wouldn't use this to do Intune deployments to desktops on flaky internet connections, as he found out really easy when he tried to do it over some crappy Wi-Fi. Like again, it will still work. It's just going to fail fast, and you're just going to have to retry it a whole bunch. But the big thing about it is that it's meant for those pipelines, and in fact, it has its own GitHub action. So if you have a pipeline that needs to install PowerShell modules, ModuleFast action, this is a GitHub action that just lets you, just all you have to do is put the GitHub action in your thing. And if you have a requirements file, or if you have that requires line at the top of your script or module or whatever, it will automatically detect it and install all the modules that you need to run that in that GitHub action, just real fast like that. I use it too for when I'm building PowerShell containers, runtime containers. This is a whole separate thing, but let's see, is it going to come up in? I was wondering if I show up. Nope, I still don't have really good SEO yet. Oh, I'm not bad. I'm 3. That's for having only created it not that long ago. All right, so these PowerShell runtime containers, I create. Microsoft no longer. Well, they never really did, but they announced very recently that they're not generating containers anymore for PowerShell. You need to use the .NET development SDK if you want anything. These runtime containers are built for running scripts in production. And they're very fast, small, high performance, and minimal security area, like as small as they can get, so that they're designed to be able to run, like one of these runtime containers, that's what runs the PowerShell gallery sync. It synchronizes the entire PowerShell gallery using Sleet in just a little container that runs as a job. So in the example of this, when I want to add modules, here's an example of that container running. But like if I have this and I want to build it, as I mentioned here in the bundling, here's a script with modules example. Probably have to go to the code. Yeah. So I have to do it. It's in the Docker file. So here in the Docker file, I just have install ModuleFast to the module as part of the build process of the Docker container. And in the module, it has my requirement, which is just the requires there. So I don't have to have a separate thing. I don't have to tell ModuleFast. I just told ModuleFast by virtue of me saying I have this requirement for this module. And when it goes to build my container, it goes out, fetches it, grabs it real quick, and the container's built. And now that module is built into my container. So it's part of the build process for this or Azure Functions. Like if you do Azure Functions, you use manage dependencies, how bad your cold starts are. So our Azure Functions, if they have a bunch of stuff like a bunch of graph modules or whatever, when we build our Azure function, we use ModuleFast to pull in those modules first and then build them into the zip file so that whenever that thing starts, it's already got its modules. It doesn't have to go anywhere else. So it's one, it's more reliable, and two, it has faster cold starts. So that's kind of the general purpose of ModuleFast, is to just plug that gap between, again, install PS Resource Get and PS Get version 3. That team puts a lot of hard work into it. They have a lot of issues with compatibility and such that they have to, they're fulfilling that PowerShell promise of keeping things compatible and forward compatible. But the unfortunate end result is that some things slip through the cracks, or some things they just don't have the manpower to do. And to do things in a performant way like this was just something that they just weren't going to be able to make that work. And for us, that wasn't fast enough. It's fast in the context of what it is, but it wasn't fast enough. So we had to build something that was better. And so that's where ModuleFast came from. Yeah, the only other things I could think of with Excel, I guess I can show with ModuleFast, there's a syntax with ModuleFast, which is really nice. That, like, say you need, make this, blow this up here again. So I do install, I'm just going to do destination module. Come on. Yeah, we'll just do module test. This is just to show, just to prove that, just so it doesn't use the local stuff. Not install module fast. And of course it comes with an alias, so you can just do IMF to do it the easy way. But so what I can do is when I specify my module is, like, a typical thing is to do like pester, for example. That'll go. Yeah, it's going to warn me about a thing. So there we go. So I got my what if and I have my pester there. One thing that's not really shown about what if is what if doesn't just have to be messages. So if you do plan to this with what if, notice it doesn't do there. You can output objects with what if. So if you do a what if and you save that to a variable, you now have a declarative plan that you can now pipe into install ModuleFast, and now you have a declarative plan for that. It will always install 5.7.1. Even if a newer version comes out, it's sort of like if you've ever used like a lock file and like package JSON or that kind of thing. This is a way to make sure, like in a CI/CD pipeline, you can commit that plan and say, make sure every time this thing runs, it's always going to get this version, so it can be predictable. And then you can choose to use like a Dependabot or something like that to bump your revisions predictably, so you don't just suddenly get a 6.0 pester that breaks everything. But let's say you still want to get like bug fixes. You still want like 5.7.2, 5.7.3. So sorry, I was just going to show this. See, so now it just is going to install that without even doing the calculations. But what if you want like you want a different version? So a real common thing in the PowerShell repository is that they still don't have. They haven't rewritten their test to work for Pester 5. So what I can do is, if any of you have ever done this before, if you do install PS Resource, you have to like module name equals this, maximum version equals, not very ergonomic. So I actually have a shorthand that lets you specify these. All you got to do is Pester less than 5. And so that says minimum version that. You can also do, less than equal. You can do a range. You can do at and do like 5.6. And you can say whether you want 6 included. This is the NuGet style syntax, which you probably see with PSGet version 3. You can say, I want everything but 6. And you can specify it in all these different ways. So I'm just going to show, for instance, if I do less than 4, what if... I didn't do all the destination stuff. Let's just go ahead and do... destination. Why is it mad at me? Oh, because I did what if twice. So see, this will make it so I always get version less than 4. If I want less than 5, I can do that too. If I want pre-releases, if I want less than 6, I'm always only going to get the production version. But if I want pre-releases, I can add an exclamation mark in here, and now I get 6 alpha. So it also gives you this really nice, and you can specify all that syntax in the command line thing. So if I go back to, this will be the last thing before I wrap up. I swear. So just as some examples here that I have in ModuleFast, so here's all the sort of different formats you can do. It also supports, if you ever use like PS depend, it supports that too. Here's all the different places you can save it. It supports, if you make that lock file, it supports the lock file. And then finally, I just wanted to show the examples of like what those spec formats look like. If we go to the test here, here's like, or you can make a JSON version. And so you can say, I want PowerShell 2.0 nightly, pester at this version. And so if and this also should work with web addresses. So if I do install, I don't know if it'll work with a Git. I probably need the raw. So if I say that, dash what if, no, it's going to get mad at me. Oh, it's because I didn't do it as a spec. I think it needs to be dash path. Nope, it's going to fail on that because I didn't fix that. Okay. Go back to where I actually have ModuleFast. We'll just do this local. Test, mux. And I'll just do it in the folder. And if you do it in the folder, you can just type install ModuleFast if you have the thing there. Post debug what if. And you'll see it'll go through and it'll find that spec file and automatically install all those modules in that configuration that you asked for. So that's it. Thank you very much.